problem asks a 0.22 ampere current is charging a capacitor that has circular plates of 9.9 centimeters in radius. The plate separation is 4 millimeters. What is the time rate of increase of electric field between the plates? I start the problem by sketching out a very crude model of this particular capacitor. I then immediately go down and note that the electric field between a parallel capacitor is simply the voltage divided by the spacing between the plates. Of course, I can also re-express the voltage across this capacitor by the general equation for capacitance, which is V equals Q over C. In particular, for a parallel capacitor, that the expression for the capacitance of such a capacitor is E0, which is for free space, if there's no dielectric in between, times the area of the plates divided by their separation. I then put that in the formula for the electric field for this specific capacitor. And in doing so for this parallel capacitor, I find that the field that exists across between the plates as a result of the plates being charged will be the charge that's on the plates at that instant divided by E0 for free space. There's no space, no dielectric in this spacing, and divided by the area of the plates. I then realize that when in the process of the capacitor charging, that the charge is changing every instant, and I represent the fact that the charge is changing every instant by a dq dt, the rate at which the charge is changing, so that the time rate at which my electric field is changing between the plates is simply 1 over E0A times dq dt. I then put in the specific values of 0.0308 meters squared for the area of each plate. My constant, the electric permittivity, is in free space is 8.85 times 10 to the minus 12 coulombs squared per Newton meter squared. The rate at which the capacitor is being charged, of course, is since it's DC current, it'll simply be the DC current. And I convert that to coulombs per second so I can get my proper units. And in putting it all into that expression that I have up here, I then separate out numbers in units, and thus it reduces to the simple expression of 8.007 times 10 to the 11th volt per meter seconds. And of course, that is the time rate of increase of electric field between the plates of this particular capacitor while it's charging at the rate given by that current. Thank you, Tate.